Your thing's glitched.
I don't know what happened. I probably tapped it with my arm. But here's what we have so far. There. So if you want to know what the problem equals, if you know the variable, like not the variable, exponent. When I is raised to an exponent, divide by 4, your remainder is either 1, 2, 3, or 0. Okay? So if you have a remainder of 1, then it will be equal to I. If you have a remainder of 2, it will be negative 1. If you have a remainder of 3, it'll be negative I. And if you have a 0 remainder, it's just 1. So A plus BI are complex numbers. All real numbers are in the complex number system. So A is part of the real numbers. And BI is the imaginary part. I should have. But then if I did that, we'd have lots of comments and snickers, and then it would take away a lot of time from the notes that I'm trying to go quickly on. Just kidding, I just did that on purpose. Okay, so we're doing some examples here. And I want to do an example of a complex number. So if you see a number that looks like 3 plus 5i, we just call that a complex number. A real number in complex form would be 6 plus 0i. So all real numbers are still complex numbers, but this particular one will then be only real. And then we have the imaginary numbers. Imaginary would be like 0 plus 5i.
Or 3i.
Or 3i, whatever.
That looks like an SI, so.
Okay. When we have an imaginary number in the denominator, we have to rationalize the denominator. Remember, we can't have irrational, we can't have imaginary or complex. We can't even have complex numbers. Yes.
So, if we have I in the bottom, can we just to the 4th power the whole thing?
Oh no, you can't just willy-nilly raise things to the 4th power.
Why not?
It won't be equal to the same thing. So what we do is we try to times by a fraction that equals 1.
Well,
So the
we
fraction I
times
divided
I
by
over I times I over I times I over I.
then we're just timesing by 1 and you still have an I in the denominator.
Well, what if you times by negative I over negative I?
3I over I.
So let me show you. If you just do by I over I, you don't change the value of the fraction, but you no longer will have an I in the denominator because that becomes a negative 1. So it's just negative 5I.
Wait, I have a question.
But you can make it positive by saying negative 5.
Okay.
Oh, never mind.
Okay. It's coming. Yep. Okay, Spencer.
Can you do the square root of I?
That's just the 4th root of negative 1.
Okay.
So probably not.
True.
So when you have, I want to show you when you're adding them together. So if you have A plus BI plus C plus DI. Snicker, snicker. Okay. So all we do is we add the real parts, A plus C plus, then we add the coefficients of the imaginary parts, B plus DI. It's really just like adding if I were a variable. So you have to combine, it's like you have like terms. If you're subtracting, you take the real parts, so you subtract A minus C, then plus, and then you do B minus D I. Unless B minus D becomes negative, and then you would change the plus to a minus and leave it positive. I don't know if that makes sense. I'm going to show you an example. So if I have 11, I'll show you. It's really a lot more simple than this. So negative 6 minus 7i. So you just take the real parts. 11 minus 6 is 5. take the imaginary parts, 2 minus 7 is negative 5, and put your I there. That's all it's saying. It's just like adding like terms. Then if we had 8 minus 4i minus 8 minus 16i, you just have to remember to distribute your negative sign basically. So 8 minus 8 is 0. Negative 4i minus negative 16i is like 12i. And that would be the answer. Now I don't know if they talk about the conjugates. I don't see it at all, but maybe it's later, some point in time. If you're rationalizing, like if you have one of these complex numbers in the denominator, you have to multiply it by the conjugate over the conjugate, just like we do when we're rationalizing the denominator. Gets rid of the I, but it's a little bit different than when we have a square root. Yeah.
It talks about the conjugate in example 2.
Oh, does it?
Yeah, and with
Thank you.
the,
Thanks, Nana.
sorry,
No, it's good. I was kidding. I'm kidding.
okay,
Alright.
It's kind of prominent
thank
here.
with the, yeah, well,
Oh, my book's different than yours.
when you would do up further, it was saying 5, over I times, you're rationalizing the denominator.
Mm-hmm.
Why would you get negative 5i?
Because when you do I squared, that equals negative 1. So
Okay.
5 over negative 1 is just like negative 5.
Okay,
Yeah, so I kind of skipped that step, but
no.
good question. So actually, my example 2 must be different than yours. So let's, I want to show you how
You want my book?
if
It's up for
you,
adoption.
if you have a fraction that has a complex number in the denominator. So let's say we had 6 over 3 plus 5i. So you multiply by the conjugate, 3 minus 5i divided by 3 minus 5i. So you have 6, 3 minus 5i divided by, so 3 times 3 is 9. The middle terms cancel out. 5i times negative 5i is a negative 25. No, it's positive 25. Because you'll get a negative 25 and then I squared is negative 1. So it becomes plus 25. So 9 plus 25 is 34. And I can reduce by 2, 3 minus 5i over something like 17. And you can distribute the 3 if you want, or you can just leave it like that. But at least we don't have an imaginary number or complex number in our denominator. Imaginary is what you want to say. Yeah.
So it's basically just like the square root conjugate.
Mm-hmm. Yep, except in the square root conjugate, you subtract the square of the second one, because it's the difference of two squares, and this one you want to add.
What?
Okay. So when you're doing the square root,
Yeah.
it's the difference of two squares. So you would, if this were just a square root instead of an I, it would be a minus right here. But then this, if it's an I, it becomes positive because I squared is
the
negative.
thing multiplies and then yeah.
Okay, Grant.
How would you graph y equals x to the or I to the x power?
You don't.
You don't.
But
So the complex plane is the x-axis is your real number and the y-axis is your imaginary part. So to graph 8 minus 4i, you would go to the right 8 and down 4 dot. That is the point, 8 minus 4i in a complex plane. But we're not going over that right now, I don't think. Okay, time's up.